Hey everyone, in this video, I'm going to explain how we can add a new server to our Agentic AI, which is going to provide the memory to our Agentic AI, and which is really important if you want to take your Agentic AI to be ready for a production use or a real-time use. That's the one advantage. The another advantage you're going to get when you have a memory server attached with your agentic AI is you can increase the performance by just not to go to the external system every time for the activity or the task which has already performed in the past, because you are going to save that into the memory, and your flow will always start from first looking into the memory rather than going for the external system to get the information. So let's get into the demo part and see how we can implement that. But before that, let me just send one particular task where it will first hit the memory to see whether any activity can be answered with the stored information or not. So for that, as you can see on my screen, I have already implemented that and I'm going to explain the line by line code. So this video is going to be a little bit longer. So stay with that if you really want to understand how the agentic AI can be configured for the memory server. So the task which I have taken, which will precisely represent the logic of memory so that you can understand in a very simple way. What is the task I am assigning? Who was the first person to walk on the moon? Please remember this fact for later. You have to keep in mind this fact. And then now, based on what you have just learned, who was the first person on the moon? So basically what we are saying, you have to first check, who is the first person walk on the moon? If you have that information, okay, it's good. If not, then you have to make the call to the external system and then save that information as a fact so that in future, if someone asks a similar question, you don't have to go to the external system. You can just take out that information from the memory. So let me just run this because it is going to take some time. I was thinking that once we have a memory, my agentic AI performance will be increased, but now I am observing a positive, right? And I'm going to explain all these observations which I have and the problem which I face, which are really interesting and challenging, and everybody has to understand, whosoever wants to build their own agentic AI, what kind of problem you get into the agentic AI when you include a memory along with having lots of external tool or the system or the server to interact with. Right. So before we get into the coding part, let's quickly understand how the flow should look like. We ask this task, right? So what agent is going to do? Agent start with the thinking. That is the very first thing. So it asks, okay, do I already know this? And for that, it will just go to the memory and try to see whether that information is there or not. So it is going to create this JSON, which it will fed to the MCP client. And then we have a new memory server, which will just look for this tool, whether the recall tool is there or not. And this is the structure in which it is expecting the arguments to be shared, right? So agent LLM analyze the first part of the request following its operational loop. Its first instinct is to check its long-term memory to avoid unnecessary work, right? So that's completely makes sense because this is what we want. So now we have to instruct our LLM. First, always it has to go to the memory to see whether that activity or the task has already been executed in the past or not. Once it does that, then the request from MCP clients to go to the MCP server, basically the memory server, look for this tool and pass this information, and based on that, it decide which tool to be executed. If this task has executed in the past, then it will say, yes, there is information. Otherwise, it will respond back like no relevant memory form for that query. Now, again, agent got this response. Agent again has to think. Now it has to make a request to the external system. But which MCP server and which tool it has to execute. Obviously, this task is something where it has to do the web search, and that's the reason it will figure it out whether the web search server is there or not and what tool web search basically, and then this is the query it is going to send, and which quite makes sense, right? If you have watched my previous video, you can understand how this web search server actually works. Once web search finds the answer, it gives the result back to the client, and then client will just communicate with the agent, and then agent again think, right? Because it has to memory that. That is what the next activity which we are saying. Please remember this fact for later, right? So it means that now it has to again reach out to the memory server and say, this time you don't have to look for this, but you have to save this information so that in future I will refer if similar activity or task come to my end. right? So in this time, if you see server name is same memory, but this time the tool is memorize. So basically we need to build two tools, recall and memorize. But this time the structure is a bit different. When we are recalling, we are using a query as a key, but now we are using fact as a key. And that is where, the task make little bit of, understanding. Like you have to say this as a once this MCP send this request to the MCP server, then MCP server, save this information in their long-term memory and give the response back to the client. Once that information is done, then agent thinks, now for the second question, which what was that question, right? So who was the first person? Now, based on what you have learned. So basically now what we are saying, since you have already learned it, now I want to verify whether you have learned correctly or not. So it means that agent has to again think, whether this, you have done your memorization of this fact correctly or not. So it means that again, it thinks, okay, what is the next activity pending for accomplishing this task? This is where it will say, I need to verify whether the learned information is correctly being saved and it is being responded when I'm asking memory server to respond for that, right? So now it is just checking. It is this time again, it is calling recall, and then it says, okay, first person on the once that is done, if the answer is correct, then it gives the final answer back to the MCP client, and then agent again think about it. And then this is the final response which we are expecting. And this time it has not gone to the external system. This is that search arguments. Right. These things we have already done it. But the good part is, this is the final conclusion. And these are the 3 points which we got. Right. So how we have to implement that? Now we can see the isolation of the dependency. Why this is important in this case, right? You just provide the memory, right? So now we can see it got into some error, and I know these kind of things will keep happening. And this is where, the problems comes into the picture, right? So let's come back here and see what kind of error we are getting, right? So there are a few errors which says agent unhandled error in a task. Good, right? So there are some unhandled error. Oh, because the database was not running. Okay, this makes sense. It means that I have to handle this more gracefully because now it's not saying whether which server is down. So this is again an improvement area for me to do now, right? So let me quickly start the database server. Right. So I hope now you guys know, what the flow should look like when you are implementing a memory. So, right, awesome. So now our Postgres is up and running. Okay, so we can come back here and we can just restart the server. Okay. Cool, cool. Now we have a server up and running, and this time we should be having no problem. Right. So I will handle this situation more gracefully so that in future, if someone asks the same question and if any server is not up, then our agentic AI should not be stopped. It should just give this information of this particular server is not up and running. So that is something, the improvement which I have to do, and I will do in a next video. Okay. So this is what I will just requested the same task, and I have explained how the agentic AI should behave on all these. So this is what the 3 things is, like isolate dependency. Now, just to implement a memory, right? Let me just go back to the code base and explain it, right? So this is a new server, which is memory underscore server. Just to implement that, you need 2 important libraries. The one is faiss, which is a Facebook Artificial Intelligence Semantic Search, which is a lightweight in-memory vector DB. You can use Pinecone as well if you really feel that Pinecone is something which you will be needing, and there are not many vector databases. And if you want to understand how the vector database works, I have one tutorial series which explain, how the vector database actually help in, large language model and AI tools. The next thing you need is a sentence transformer. Again, this is a library which helps us to utilize the large the embedding models. So here we are using a very lightweight all mini LM LS632, which is actually going to just create the embedding based on the simple text or the plain English. So what we have to do, we need to install these 2 libraries which are very heavy in nature, and that is where the MCP server comes into the picture, because it isolates the not only the dependency, because this entire logic is running under the server, and that server will be hosted in a real time on some machine. So we are completely isolated with that, and irrespective whether these libraries are so CPU intensive and how heavy those are. right? So this is the faiss CPU. You can just directly install this and you can just understand what it does. It's very straightforward. Then we have the sentence transformer, which actually helps us to just create the embedding and do the semantic search or the re-ranking. And for this, as I mentioned, I have already explained all these concepts in my different tutorials. One tutorial is for the vector database. Another one is for the how to utilize the RAG with the large language model. And you can watch all those, videos on my tutorial series. So this is what the sentence transformer, embedding model is, how you can use it. You can just get this information here, like you can import this and you can just use this model.import and then it will just give you the embedding, which is nothing but numerical representation in an array form. Again, the another thing which you need is NumPy because faiss actually understand only the NumPy array. So you will have an embedding, but it is having a very close, compatibility with the num. So you have to just convert that embedding into the NumPy so that you can fed that to the faiss, which is, the vector database provided by the Facebook. Right. The next thing is all things are pretty standard. The thing is where you have to keep in mind this information, like which file should have this vector DB information and which should have all the information about the text which we are sending to the faiss vector database. And then we have to initialize the encoder with the sentence transformer and which encoding model we are using, this one, so that we can just convert that any text into the embeddings, right? Now, what you need a dimension. So basically, if you just see the dimension, this particular model provides 384, but still you can get that so that you don't have the dependency. If in future this dimension gets changed, then it will be automatically handled by the logic, right? The first thing is we have to initialize the memory because, if you are running for the very first time, you have to check whether this particular file is existing or not. If this file is not there, it means that you have to create that, right? So it will create it. If this file is already there, it means that you can just read the information from there. And that is what we are doing here. We are just checking the existence and accordingly we are deciding what needs to be happen, right? So if it is already exist, it means that we have to read that, and that's the reason we are saying we are using this read underscore index so that we can just use this index to search the record. But if we want to create that, then definitely we need this write underscore index. So these are just a simple way how we can utilize this library, and then we are just opening it for the write. So here we are opening this for the read, and here we are opening this for the write, and that's the reason we are using JSON load here because we want to read it, and here we are using JSON dump. If you are coming from the Python world, you can easily understand all these things. Now, as I explained how this task is going to be executed by our agentic AI, as I explained, we need two tools, right? Memorize and the recall, and that is what this uh, uh, right? If I just go up here and if you just recall, when it is recalling, it is sending this structure, right? Query and then exact query, and then if it requires to memorize something, then it is calling this memorize tool, and this is the structure where we have a fact as a key, and that is what you can see here in the method signature, right? So memorize with fact as a key, here recall as a query. And then, you have two global variables like the index and the memory text data. Memorize means you have to read, you have to write the data, so whatever the string is coming first, you are converting into the embedding, and then you are using this index, which is actually calling a write underscore index method object. And then we have this line. And now the important thing is, as I mentioned, this faiss required a NumPy array, and that's the reason we are feeding this embedding to the NumPy array and saying data type should be float 32, right? And then we are just tiling. Similarly, when we have to read it, it's pretty much a straightforward thing. Now, this time we are using an index, which is actually calling a read. This one, read index object, and then this index is actually searching. So for what query to be searched, and that is where this query will come. So it will just convert into NumPy array for the embedding. So first it's converting into embedding, then we are having a NumPy array, and then we are using the same data type, and then we are saying, okay, we need the first three records which are having a most closer semantic search score, and based on that it will provide you the memory. And what we are doing here, if you just see what we are getting here, the very first record which we are extracting from this one, right? We are extracting three, but we are returning only the very first one, right? And again, this is the very standard. So this is what this memory server is actually doing. Let's come back here and see if agentic AI is able to perform the task or not, and it is doing the way which we are expecting it to do, right? So now if you just see all tool servers are running, thinking server web search, right? So it seems to me like it is not hitting the memory server now for the first, right? So this is where the problem is. It's directly making a request without even just go to the memory first and just look whether, that information is stored or not. Right. So the very first step should be it should recall it, but it's not doing it, just making a request to the web search external. Let's understand these are the problem which you're going to face when you are going to build this agentic AI. And that is where you have to just think how you can handle all those situations. So the very first thing expectation was it should go to the memory server first to check whether this information is there or not. But the very first thing what it is doing, it is directly making a request to the external system, right? That we will figure it out why that is happening, because we have already understood how the memory search server, how the memory server is logically coded or implemented. Now we're gonna see how we are just implementing that into the agentic in our agent, right? Because we have to add this server and then we have to create the prompt as well. And the prompt engineering will be having a more importance here because now we have a large number of MCP server along with the tool. The second step in a thinking, if you see now it is making a right choice because it is now thinking, okay, now memory and we have to memorize that, right? So now it is creating this fact, which is what we are expecting, right? The result is memorized. That's okay. Then the next thing what it is doing, it is now recalling it. That's again also good, right? And final answer is based on this memory. The first person to walk on the moon is a Neil Armstrong, right? So the only problem which we are facing here is that web search, right? So let's quickly run this task one more time and see what is happening. So we have to just keep in note that, the very first step, large language model make a little bit of mistake, and then we have to see how we can handle this with our prompt. So I'm going to run this same task again, and this time first it has to go to the memory and see whether this using a recall tool to check whether this information is already there or not. Now, coming back to the coding part. So this is what the memory server is like. So now we know the next step is we have to register this onto the agent cells, right? So this is where we have servers to manage. So this is the line which you have to make it here, right? So you can tell, okay, where the server can be formed by the MCP. Now if you just see, I mean, this is what the previous so the prompt you are viewing, right? So this is how we will do it. If you just enter, this server information here, and if we don't use this section, right? Because now we have to direct our large language model, how it should structure its thinking. Because if we don't control this, then it will always go to the web search, and that is what we want to restrict. And that is why I'm saying the prompt engineering plays a very important role when you have to build the agentic AI. When you have a large number of tools in the server, then you have to define a lot of things. And for that, I am just trying to create another application which will provide the prompt based on the tools, external tools, internal tools, and the memory which we have designed for our agentic AI, right? Just for now, you can understand. Sorry. So this is what the information is. I just added a server, and how many tools we have? We have two tools, and then I have just given, okay, this is the method structure. Like if it is recall, then it is query, and if it is memorize, then it's expect from, right? So this is what we have here. Rest of the stuff is pretty much same because we wanted to follow the same structure, but this is where we have added information where it says the core task and the decision making process for the large language model. And for each step you must follow this logic, right? So first it has to recall first, then it has to act if necessary. If memory is empty or the recall did not find the response for your question, then only you have to decide for the rest of the tools whether the external tools can be required here or not, and then eventually you have to memorize that. So in the future tasks, you don't have to go to the external system. But it seems like, I mean, this is not working, and that is what the uncontrollable situation which we have to handle in a more interesting or more innovative way, right? But for now, let's see if in a second chance, if it is doing the right thing or not. So it's still taking time, so it's still making a request. So all the servers are up and running. Now this should be done. Let me just quickly pause that because it is going to take a little bit of time to just complete this activity. And I'll just come back. Okay, now it's done. So I don't have to pause the video. Okay, now we can see what it is doing, right? So now it is able to figure it out, because what the very first step it is doing a memory, it is just hitting the memory server, then the tool is recall, which is right. And then it says, this is the query, who was the first person to walk on the right? Then it get the answer, and then it's finally responded back by, okay, this is what the answer is. So for the second time, it seems to be working fine, but for the first time, it was having a problem where it is not, not directly, hitting the memory, but it is that's directly going to make the request to the external system, right? So now this is the another problem, right? So the very first problem which we figured out is, the way a large language model is thinking to first hit the memory, it was not doing for the very first request. It means that we have to make our prompt more stronger, where it has to dictate clearly that the very first step which you have to do to go to the memory, which was not happening for the first time for this particular task. So definitely we have to just improve our prompt, right? The second thing is, rather than increasing the performance, but definitely if the information is already there, then the performance is being increased. But if the task is having all the activity which is not yet executed, the performance is still very slow. It could be because of the database, or it could be because of this memory. So we really need to figure it out, and that is something which I will be taking care in the next part. Right. So the prompt engineering, which is actually giving a very hard time. If you just see the another problem which I want to highlight, I want to really show you. This is what the problem is I was getting when my prompt was not properly designed with this instruction. Right. It was getting into the infinite loop sometimes. Sometimes this just keep looking for the web search again and again. So that's the reason I'm saying the prompt engineering is really important when you want to build the agentic AI. Right? That's one thing. The other solution which I can think of all these problems are related to the fine-tuning a model. Since I am using a Gemini Pro, but if we decide, okay, our agentic AI is already good, is only going to work in this particular domain, then what we can do is we can just fine-tune our model based on the domain information. Then also, we can, get the consistent result from the large language model. The other thing is we can use the RAG-based system as well, so that we can control, the how large language model respond to these different servers, right? So there can be these solutions, right? Okay, the very first thing is improve, to create the prompt at the runtime based on the request or the task which agentic AI is getting in the hand. The second thing is we can fine tune the model in a specific domain where we want to optimize, because right now it's a very generic agentic AI, but if we know that for which domain or for which industry we are building this agentic AI, for what purpose it is going to be used, then definitely we can fine tune it, or we can just use the retrieval augment generation strategy as well, or we can combine all these three, like we can improve the prompt engineering, we can fine tune the model, and we can use this RAG as well. So this is where, the open-ended question for me, how I want to handle this situation. In the next video, definitely I will just explain how we can handle the situation where large language model will not get into those confusing state where either it will just directly hit the external system rather hitting a memory, or it will just goes into the infinite loop, right? So that's it from my side for this video. I know this video is a little bit longer, but I cannot help on that part because this is what we have to uh, do. And I know this is a very complicated, concept to understand, right? And I don't want to make a false, commitment here that you will understand in a very easy way. No, it's not. It is not easy. You have to be very curious. You have to put a lot of efforts to learn all these concepts which I have used, right? So now just to recap, now we have five servers: the calculator, database, file system, memory, and the web search. Prompt engineering is really something which we have to look into the more deeper, and we have to see how we can modularize and dynamically generate the prompts, based on the task, based on the number of servers and the tools we have. The other thing is we have to really think about how we can use a fine-tuning strategy or the RAG strategy, or we have to combine all those three concepts like prompt engineering, the best prompt engineering, the fine-tuning the model, and the RAG. So we really need to think about it thoroughly how we can utilize that, right? So that's it from my side for this particular video. I hope you really enjoyed it. If you really like this video, give a thumbs up, and if you haven't subscribed for my channel, please subscribe for my channel as well. And as always, thanks for watching this. Stay healthy and keep learning new things.